Next, let's discuss about combination of capacitors. So do you remember the combination of resistors? We could connect resistors, or we could combine resistors in two ways. One is series and another is parallel. Similarly, we could combine capacitors as series and parallel. Okay, so capacitors can be connected in two ways, series and parallel. So first let's discuss about series combination of capacitors. What do you mean by series combination of capacitors? If capacitors are connected one by one like this, so here the capacitors are connected one after the other, end-to-end connection. It is known as series combination. Okay, and this is connected to, all the capacitors are connected to a battery in a series way. Now, when the circuit is switched on, what happens? The charge starts to flow from the positive terminal of the battery to the first capacitor. So let the capacitance of first capacitor be C1. Then that charge Q flows through the first capacitor C1. Again, after crossing the capacitor C1, the same charge Q flows through the second capacitor. Let C2 be the capacitance of the second capacitor. After crossing the second capacitor, the same charge Q flows through the third capacitor, and let C3 be the capacitance of the third capacitor. And after crossing the third capacitor, the same charge Q flows towards the negative terminal of the cell. So the same charge Q flows through all the three capacitors. So this is the peculiarity of series combination. Charge will be same. But what about the potential difference? Potential difference across each capacitors will be different. So let the potential difference across the capacitor C1 be V1. Let the potential difference across capacitor C2 be V2. Let the potential difference across the capacitor C3 be V3. So the potential difference will be different. Then what will be the total potential difference? Total potential difference V will be the sum of potential difference of all the three capacitors, that is V1 plus V2 plus V3. Now we know the general equation for V, that is capacitance C is equal to Q by V, right? And what will be V? V is equal to Q by C. So if V is Q by C, then V1 will be Q by C1. No need to write Q1 by C1. Why? Because the charge Q remains the same. And V2 will be Q by C2. V3 will be Q by C3. Okay. So substitute the expressions for V, V1, V2, V3 in this equation. So you will get, instead of V, we can write Q by C equal to, V1 is Q by C1, V2 is Q by C2, V3 is Q by C3. Now this Q is common factor, so it will cancel on both sides. Then we have 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So this 1 by C means it is the equivalent capacitance. Okay. So if capacitors are connected in series, what is the formula or equation to find out the total capacitance or equivalent capacitance? It is 1 by C1 plus 1 by C2 plus 1 by C3. If you have n number of capacitors, the formula can be written like this, plus etc. plus 1 by Cn. Just opposite to the resistor combination. Okay, for resistors in parallel combination we have similar formula, but for capacitors in series combination we have this type of formula. So for when capacitors are connected in series, how will you find out the equivalent resistance? Using this equation, 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3. If there are n capacitors, it will be 1 by C1 plus 1 by C2 plus etc. plus 1 by Cn. Now the quantity that you obtain after calculating this sum won't be the equivalent capacitance. It will be just 1 by C equivalent. So if you want to obtain C equivalent, you need to take the reciprocal of this expression, final expression. Okay. So when the capacitors are connected in series, the total capacitance will decrease. Okay, just like the parallel combination of resistors. So when capacitors are connected in series, the total capacitance decreases. Now let's discuss about parallel combination. So what type of combination is parallel combination? You are familiar with the parallel combination. See, when the capacitors are connected like this, this is parallel combinations. So here the initial and the final points of these three capacitors are same, and let these points be A and B, and connect these points to a common battery like this. So here all the three capacitors share the same potential, that is V. So the potential difference across each capacitors will be same. When the circuit is switched on, what happens? The charges starts to flow from the positive terminal of the cell. Okay, and these charges reach here. On reaching here, the charges will split because these charges will find three different paths. So they will split, and Q1 flows through the first capacitor. Let its capacitance be C1. Charge Q2 flows through second capacitor. Let its capacitance be C2. And charge Q3 flows through the third capacitor. Let its capacitance be C3. Okay. So here the charges flowing through each of these capacitors will be different, but the potential difference will be same. So for a parallel combination, charges will be different, but at the same time the potential will be same. Okay. Now charges are different. So what will be the total charge? Total charge Q will be sum of Q1 plus Q2 plus Q3. Okay, so what is Q? Q is equal to CV. Okay, then what will be Q1? Q1 is equal to C1 into V. Q2 is equal to C2 into V. Q3 equal to C3 into V. Here no need to write V1, V2, V3 like that, because the potential remains the same and it is V. So substitute the values of Q, Q1, Q2, Q3 in this expression. So we will get Q is CV equal to C1V plus C2V plus C3V. V is a common factor on both sides, so it will cancel. Then we have C is equal to C1 plus C2 plus C3. So this C is C equivalent actually. That means the equivalent capacitance of parallel combination. So if there are three capacitors which are connected in parallel combination, how will you find out the equivalent capacitance? Equivalent capacitance is obtained by adding the capacitance of all the three capacitors. And here the total capacitance for a parallel combination increases. Okay. If there are n capacitors, we can write the equation like this. C equivalent is equal to C1 plus C2 plus C3 plus etc. plus Cn. Okay. So this is about the series and parallel combination of capacitors. So for a series combination, the total capacitance will decrease. And the formula to find out the total or equivalent capacitance is 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus etc. plus 1 by Cn. For a parallel combination, the total capacitance increases. The formula to find out the equivalent capacitance is C equivalent equal to C1 plus C2 plus etc. plus Cn. Okay. So children, that's all for today's session. With this I am concluding my session. So notes of the topic and YouTube video have been uploaded. Just go through it. attend the test seriously and post me the answers quickly. We can meet in the next session. Till then, take care. Stay home, stay safe. Thank you.